Over the years, we have noticed that a lot of the questions in week 1 are about these memory operations and floating point operations. So we finally have decided to go ahead and just put a quick video about this together. So what's going on? Well, let's take the XP operation as an example. We're doing a scalar times a vector plus a vector. And here we have a concrete example of vectors of size 3, where we want to do 2 times the first vector and add it to the second vector. And you've learned that that means you do this times that plus that for the first element, this times that plus that for the second element, and so forth. Now, imagine that all of this data starts by being stored in the memory of a computer. In week 5, we have an enrichment that talks a little bit about the hierarchy of memories, but for the moment just assume they're in the main memory. And the other thing you need to know is that in order for a processor to compute, data must be brought into registers, and there are only a few registers. So let's give a very simple explanation. This data is in main memory. We have these registers, and we notice that the number 2 here gets reused many times. So what we can do is we can take 2 and we can load it into a register and keep it there during the entire computation. And that costs us 1 memory operation. Okay. Now, for each pair, 1 element from X and 1 element of Y, what do we need to do? We need to read these 2 elements, and we then need to write the result back into Y. Okay, so that means 2 memory operations for reading, 1 more for writing, so that gives us 3 memory operations. And what do we do with those elements? Well, once we have read them, we need to do 1 multiply, 2 times 1 in this case, and 1 addition. So that's 2 floating point operations. But we need to do that for every corresponding pair in these 2 vectors. Okay? If the size of the vectors is n, then that means that we would have to do 3 times n memory operations and 2 times n floating point operations. So the number of memory operations we have to do is then 3n plus 1. And the number of floating point operations that we need to perform is 2 times n. Now often we will sort of say, well, this plus 1 if n is large enough is insignificant, and therefore we would say it's approximately 3n memory operations. And that's really all there's to it.